This week is a special crossover episode from our other show, the Machine Learning Podcast. If you like what you hear, then you can find more at themachinelearningpodcast.com. Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/RudderStack. You shouldn't have to throw away the database to build with fast-changing data. You should be able to keep the familiarity of SQL and the proven architecture of cloud warehouses, but swap the decades-old batch computation model for an efficient incremental engine to get complex queries that are always up to date. With Materialize, you can. It's the only true SQL streaming database built from the ground up to meet the needs of modern data products. Whether it's real-time dashboarding and analytics, personalization and segmentation, or automation and alerting, Materialize gives you the ability to work with fresh, correct, and scalable results, all on a familiar SQL interface. Go to dataengineeringpodcast.com/materialize today to get 2 weeks free. Your host is Tobias Macey, and today I'm interviewing Eran Yahav about building an AI-powered developer assistant at Tabnine. So, Eran, can you start by introducing yourself?
Hey, thanks for having me. I'm Eran. I'm the CTO co-founder of Tabnine. Other than that, professor of CS at Technion, which is one of the leading Israeli universities. I've been doing research on program synthesis from many years now. I think since before it was cool, and definitely looking forward to this conversation.
And do you remember how you first got started working in machine learning?
Well, I've been working on program synthesis for many years now. I think it's since the mid 2000s or something like that. And somewhere around 2010, we realized that a lot of programming tasks are extremely repetitive and can be automated if we learn from millions of examples. So initially, we worked on classical approaches, mostly logic-based approaches to program synthesis, using version spaces to represent spaces of candidate programs and explore the space of programs for synthesis. But when neural networks started to gain popularity again, and mostly when LSTMs started to be useful, I really got hooked on that. And from then on, I think really evolved together with the field closely to NLP techniques through transformers, and and the rest, as they say, is history. And really, since the age of transformers, so to speak, together with my students and with Yoav Goldberg from Bar-Ilan University, we've done a lot of cool things around the expressive power of various networks. So fairly theoretical work, expressive power of various RNNs, applications of LLMs in general for software engineering, and also did very cool work with my student Gail Weiss and with Yoav on interpretability of transformers and reverse engineering transformers. So that was a few years back already. So been in this field for a while now.
And so for the Tabnine project, can you describe a bit about what it is and some of the story behind how it came to be and why this is the problem that you want to spend your time and energy on?
So Tabnine is an AI assistant for software development. It helps you with all software development maintenance tasks. You can help you generate code, generate tests, generate documentation, review your code, and it will eventually help you drive the entire software development lifecycle end to end using AI. So back, I think in 2018, maybe we were the first to bring code completions to market, initially just in Java, based on classical techniques, let's call them more logic-based and semantic techniques. But when we moved to use GPT-based networks 2019 and extend the platform to support more than 80 languages, I started by focusing on code completions because we saw that it's a good place to deliver a lot of value to developers. But the vision is much wider. I think it's pretty obvious now that the future of software development is AI driven. So like everything in software development is going to be assisted with AI. You will not write software or maintain software without AI, just like you don't do it without a compiler, right? Or without an interpreter, doesn't matter, for interpreted languages. So the future is software development is AI driven. It will take some time to get to that point where the entire process is AI driven, but we definitely see more and more pieces of this vision materialize, right? Every month that passes, we get another task in software engineering boosted by AI in a significant manner.
For the use case of AI as an assistant to your development progress, what you mentioned code completion as the initial foray into that space. I'm wondering what you see as the main motivations that individual developers and then at the team or organizational level they start to adopt these AI capabilities into their development practices.
Yeah, so I think for individuals, it's mostly productivity and also, at least for me, also some elements of discovery. So as I'm working with Tabnine, I obviously get the acceleration of not having to think about syntax and even about the implementation of various things that either I've done a million times before and I don't want to remember, or even things that I don't know how to do and I don't really want the nitty gritty details. I just want it to be done, like calling some API or something like that. So definitely acceleration and productivity boost for the individual, but also higher quality of code and discoverability, especially with Tabnine Chat. I ask questions on how to do certain things where I don't know the answer, and I get educated. I learn stuff from Tabnine Chat. So maybe kind of a more structured answer to your question is as an individual, I feel that Tabnine serves three different layers for me. One is remind me. It reminds me things that I know how to do, but I just don't remember the exact details. Second is teach me. It teaches me how to do things that I don't necessarily know how to do. And the third thing is elevate me, like really give me wider context and make me a better developer by kind of exposing various ways to do stuff. So as an individual, it is really like working with an expert that can expose you to new things as well as reminding you kind of the non-interesting things and get them out of the way quickly. To answer a second part of the question, for organizations, I think again, it's clear to any organization that all software is going to be developed with the assistance of AI, right? So there is an AI in the future of software development anywhere and everywhere. So organizations are coming to us to see how Tabnine can improve productivity, how can it harmonize the code that is being created in the organization, right? Because when everybody is following kind of the same model or the same AI when they generate new code, you get harmonized code. They're kind of all of them are inside the distribution, so to speak. So nobody is kind of getting on a tangent, right? They're all like on the common path in some sense. And with the launch of Tab9 Chat, organizations are also coming to see whether chat can accelerate knowledge sharing and help answer questions that would otherwise require human experts to answer. So a wide range of things. And again, as the functionality of Tabnine increases to expands to code review and to other surface areas, I think we'll see even more demand from organizations.
Yeah, I particularly like that thought of having the expert sitting over your shoulder because that is one of the challenges to scaling engineering teams is that there's only so much expertise that can be built up within an individual or a set of individuals, and it takes time to proliferate that knowledge. And it's also sometimes challenging to be able to ensure that all of the people who are coming into the team are allocated enough time with those experts to be able to pick up the various signals that you receive through that interaction. And so by being able to reduce the total amount of time required to gain some of that context and knowledge, it allows that subject matter expert to scale more effectively because they don't have to spend as much of their time on staring over somebody's shoulder while they write code and try to figure things out.
Yeah, absolutely. And it allows you to kind of get things right from the get-go because you're getting help as you're generating the code. you may be generating in a way that will pass the review later, right? So it's not only that you get the expert knowledge, in a sense, you get the expert knowledge early enough so you don't have to get rejected in code review and redo what you did, right?
And the other side of that, though, is there's only so much expertise that an AI can consume or consolidate because some of that expertise is contextual and requires things that are, at least as of now, still within the domain of human only capabilities, such as intuition or being able to make logical leaps between two different things or understanding the overall business context without having to explain it in very minute detail to the AI. And I'm wondering what you see as some of the real world limitations of using a generative AI in the creative process of software development.
Yeah, so definitely architectural reasoning and high level reasoning, business kind of reasoning on why are we doing it this way is something that is right now at least beyond what the AI is capable, or at least it's not easy to communicate that information to the AI right now. Not to say that it will remain that way forever, but at this point, this kind of reasoning is pretty hard to the AI and it's pretty hard to communicate that. But I think that that's the beautiful thing about AI assistance in software development is that you can relieve the humans from like the nitty gritty details of the exact syntax of calling an API or how do I sequence, some calls to other things, and the humans can focus on the architecture and on kind of the business aspects of why are we doing it this way. And so usually when people ask me, like, like general audience ask you, are developers going to be replaced by AI? Like, are software engineers going to be replaced by AI? And I tell them, no, absolutely not, because the job of a software engineer is to solve business problems using software. It is not to generate code, right? So the code generation aspect of a software engineer, yeah, that may be accelerated or to a large degree replaced by AI. But thinking about the business problem and what software architecture and what software should be created for it is definitely in the realm of the human. But maybe to answer even like slightly more philosophically, I would say that the limitation of Gen AI in general is the human. The models are already extremely strong in their ability both to take a lot of input, be it through fine tuning on customer code, say, or using very large context windows or context stuffing or whatever other techniques you want to use to communicate a lot of information into the model. And the models can also generate very extensive outputs, right? So the bottleneck is really the human. Like, do you, Tobias, really want to read 2,000 lines generated by Tabnine and review them to see that they do exactly what you wanted, like in one vault, like here, Tobias, like bam, 2,000 lines, good luck? I don't think so. That's not how humans work. So really, the barrier to a large degree of Gen AI in general, actually, and in software creation, is the human. And we need to find better ways to communicate with the human and lowering the cognitive load on the human when they work in the system. Right now, this is done by the AI. Kind of the natural granularity of communication is a class level, method level, something like that, that you can say, oh yeah, it does what I want. But if you want to go beyond that, the barrier is not the model. The barrier is the human being able to say, yes, I understand kind of what this does, and this is what I wanted.
Speaking as somebody who's been in software engineering for a little while, it's very similar to the experience of working with the person who's requesting the software to be built and doing the requirements gathering to understand what is it actually that you're trying to solve for. And so we're just moving that another layer down where I as the human have to get the requirements from other humans, and then I as the human have to relay those requirements to the AI in a way that the AI can understand it. So it's really just the same experience, just with a different interface.
Yeah, it's a similar experience, and we would think that in the future we'll find a better interface, right? Because otherwise, as you said, we just like rolled the problem one level up or one level down. What you really want is a better way to communicate that intent, right? And to create the software in a better manner.
Yeah. I mean, as you said, as software engineers, our job is to solve problems for the business, and half of that is understanding what the problem actually is and what
Yeah.
the technologies are able to solve.
Yeah, I think maybe one positive outlook on this, as software engineers, we shouldn't be too negative and bitter. I think that the positive here is that Gen AI allows us to get the prototype faster and to kind
Exactly.
of get to a faster realization that the software actually doesn't do what we wanted and that the requirements are unclear, right? So it's a faster iteration. And I think this is extremely valuable.
Absolutely. Humans as intermediate representation.
Yeah, absolutely.
And then another aspect of AI in the software development context, and we've addressed this a little bit, but the aspect of as software engineers, we feel like, oh, we're the expert in the problem domain. We know exactly what we're doing. We don't need an AI to come and give a bunch of recommendations that might be wrong, and then I have to evaluate it. I'm wondering what are some of the aspects of skepticism that you have come up against with developers who are starting to think about this utility in their tool belt, or some of the aspects of oversight that they need to be aware of as they're starting to exercise generative AI for producing larger and larger components of their code.
So actually, I think skepticism is already gone. Like a couple years back, maybe 3 years ago, it was like, yeah, I'm not sure that this can generate anything useful. It maybe automates only the parts that, I don't care about and like very mundane stuff and doesn't help me. It's just another thing that gets in the way. But in the last maybe year and a half, maybe 2 years even, I think the technology has matured to a level that is really pleasing, and it's a pleasure to work with something like Tabnine. And you work with it, and it's like, oh, I actually didn't know that it is capable of doing that. I'm pleasantly surprised, and you get like a sequence of these pleasant surprises all the time. Not to say that all of them are pleasant. Sometimes the surprises are unpleasant, but for the most part, it's a pleasant experience. And one interesting psychological thing about the product is that people love the product. And I think one reason is that we are developers, we are fans of the technology, and we are really rooting for the product to succeed, right? We want AI to succeed in some sense. So whenever it succeeds, like, oh yeah, it got that right. That's very like we're happy for the product that it succeeded, which is a fascinating psychological phenomenon from my perspective. I think another aspect there is the variable reward. It doesn't always succeed. And so the fact that you're kind of expecting to see something and so there's some game there, right? You're playing with AI. It's playful. It's a playful thing. And the technology is mature enough that even when it fails, you kind of understand why it fails. So you treat it like a child that has not developed the deeper understanding. You say, oh, yeah, I see why you got that wrong. Let me try to rephrase my prompt, and maybe that will make you succeed, right? So there's a lot of like nurturing of the AI by the developer. Definitely, if you want to take the kind of the more critical point on that, I think the AI does act as an amplifier, right? So Tabnine is contextualized on your code. And if your code sucks, it will keep generating code in that vein, right? So if you write horrible code, guess what? The AI understands that this is what you want. You probably want more horrible code. And so it will help you create that. It will try not to, right? But it could. You could persuade it to follow your style into the dark corners of software. And so I think developers need to be aware that the AI imitates their style in some sense, and they have to be careful and keep an eye on what gets generated, especially if their current code is not that great.
Data lakes are notoriously complex. For data engineers who battle to build and scale high quality data workflows on the data lake, Starburst powers petabyte scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today. The easiest and fastest way to get started using Trino. Absolutely. And that brings to mind my other question about technical debt and managing the amount of technical debt that is generated through this interface, where it's the same garbage in, garbage out principle that you were saying, where if you write a really bad way of looping through a string, then you're just going to get more bad loops, and you're quickly going to get into a situation where your software doesn't work at all.
Yeah, it's not necessarily that bad. I mean, some of our
Right.
customers, when you step into the customer, they typically say something like, "Oh, can you train on our code?" So we get something that is similar to our code, and and then they think about it again and say, "Actually, you know what?
Let's train on
Remember
somebody else's code.
that remember that we said we have 30 million lines of code? Actually, we just want to train on the three, right?
Yeah.
The other 27 million lines of code, it's better that they don't see the light of day, right?
Right.
So I think that we're seeing a lot of that. And if you do train on your good projects, or if you kind of be careful about what you put into the context, I think you will get high quality code that you can be happy with, right? And you're absolutely right that if you're not careful, you could enter the business of producing what we call new legacy, right? You just like you have a bunch of legacy code and you're just generating new legacy code, right? So you got to be careful with that.
And that brings me to the question of some of the ways that developers and development teams use something like Tabnine in their development workflow. Is it largely for exploring new capabilities and quickly iterating on prototypes? Is it for managing refactoring workflows, generating tests? I'm just wondering if you can talk to some of the ways that people think about the AI capabilities as a complement to their existing skill set.
Yeah, I think still the most prevalent use is in code generation and code completion, just because it integrates so naturally into the flow and happens with a very high frequency, right? So every time you type, Tab9 gives you a code completion, and often it is what you want. So you just hit tab and take it. So this is definitely kind of the workhorse of AI assistant. It happens all the time. Similarly, when you write a kind of a method signature or comment inside the code, that is again in code generation style, but maybe longer form code generation of an entire function or entire class directly from the comment. This is also very widely used. Other things like test generation, documentation generation definitely happen, but just in naturally their frequency is lower just because their frequency in the software development kind of life cycle is slightly lower, right? Unless your job is just to generate tests, which happens, you're still spending most of the coding time like just writing code and not writing tests or documentations. Not to say these are being used quite often, but their frequency is obviously lower. And Tab9 chat is also used very frequently. Then it's more like what you said, more discoverability, like how do I do X, or where can I find Y, and stuff like that. So it's yeah.
The other piece of curiosity that I have around this overall set of capabilities is if there are any particular categories of software that something like Tab9 is most effective or most capable, thinking as far as web applications versus machine learning models versus infrastructure as code. Just wondering if you can talk to some of the ways that it's used most broadly and some of the cases where it's most effective.
So the Tab9 is used by over a million users, I know, every month, and so these users come from all avenues of software, all programming languages, and I think almost all kinds of applications. And even here internally in Tab9, we use Tab9 every day across the entire stack. That being said, I think that at least for code generation, that there are languages that are more amenable to kind of getting a very high, what we call automation factor, like huge amounts of your code getting generated for you. And languages such as JavaScript UI or TypeScript UI, React, whatever, you can get a lot of automation there. Definitely Python data science work is also highly automatable, again, because many times the tasks are well defined, so it is easy for you to communicate to the AI what is it that you want, and it is easy for you to judge that the result is what you wanted. So maybe taking a step back, I usually talk about the fundamental theorem of Gen AI, which holds also in Gen AI for software, which is a kind of, I call it a theorem, but it's really maybe a trivial observation that just says that the cost of specifying what you want plus the cost of consuming the result has to be much, much lower than the cost of doing the task manually, right? So if I have to work real hard to tell Tabnine what I want, and I have to work real hard to check the result is what I wanted, then maybe it would have been better for me just to do it manually. So I would say the kinds of software or the style of software for which AI is most useful or appropriate are tasks that are easy for you to define what you want and easy for you to kind of judge whether what you got back from Tabnine is what you needed, right? So it's really again the style of software is more about the where is it easy for the human to communicate with the system, both in terms of input and in terms of consuming the output. And UI is a trivial example because you can run the program and see whether the UI looks like what you wanted or not, right? And so it's easy for you to judge. Data science is another because you maybe hit a button, see the plot, and say, yeah, that's the plot I wanted, right? So things that are very easy for you to judge whether the program does what you wanted it to do.
And the other interesting piece that you already alluded to is the set of languages that are supported. You mentioned that when you were first doing code completion, you started with Java. Now that you're using generative AI, you've expanded the set of languages that it works with. I'm curious if you can talk to what the analogy is of natural language, large language models being biased largely towards English, and how that compares in the software ecosystem and some of the ways that you're looking to tackle the long tail of languages that people would like to have supported.
Yeah, that's interesting. I think there's enough code in most languages to drive a very successful model. So our current models support, I think, maybe up to, I don't know, 60, 80 languages, depending on how you count. The ability of the model to generate clever things is definitely more biased towards the kind of heavy head of languages. So you'll get great results, JavaScript, TypeScript, Java, Python, PHP, C++, Rust. So I don't know, probably Ruby, probably forgot a bunch of others, and maybe the support in Lua and Elixir would be slightly less sophisticated, but there's definitely transfer happening between languages, also in natural languages, by the way, but more so, I think, in programming languages. So you'll be surprised that even if you don't have a lot of Elixir code out there in the world, the model does pretty well on Elixir, and even more interestingly on Verilog or system Verilog code, which is also substantially different than what we're used to as in higher level programming languages. So it's not exactly the same effect like having a language model for Hebrew, which is very very challenging. There's more transfer happening, I think, between the programming languages.
Yeah, I think that the overall problem space is compressed compared to all of human language because all programming languages are targeting the same core capabilities of Turing completeness. They might have different semantics or different ways of approaching it, but they all have the same base set of constructs and capabilities that they're trying to compile down to. And I'm sure that that simplifies the translation between the syntactical elements because the core semantics are largely similar. I mean, there are obviously programming languages that have very esoteric capabilities or ways of approaching a problem, but at the end of the day, it all compiles down to CPU instruction sets.
Yeah, there's another aspect here. You're absolutely right, but there's another aspect here that There's actually the base signal, like the carrier signal, which is the programming language syntax itself. But largely what we do today with programming languages is calling APIs and libraries. And the syntax of the programming language is very, very simple, and it's easy for the model to pick that up. The model always almost does not make syntactic mistakes, right? So it's all about the APIs and libraries and how you call them, how you sequence them, etc. And that is largely shared between languages. So, if you're using whatever Twilio API in Java, JavaScript, Rust, or something, you're going to get almost very similar names for kind of API calls. And the syntax of calling a function may be slightly different, but there is some structure there that is really shared across all languages, and the model picks that up quite nicely.
And now, digging into Tabnine itself, can you talk to some of the design and implementation details of the product and application, but also some of the ways that you think about the model training and development and deployment aspects?
Yeah, so let me see where should I start? Let me start like with large blocks, let's call them. So uh, I think people don't really realize the distance between a model and a product using a model, and the model changes all the time, and new models come out every week almost, and we kind of improve our models all the time. But the model is a kind of small part of the product. There's so much going on around that. So things like vector memory that help the product be contextually aware of what's going on in your code base. Things like semantic memory that help the product be aware of semantic kind of context of what's going on in your project. So Tabnine, for example, will know things that are defined in libraries, even very deep inside the library, even when the source code of the library is not available, right? So there's some level of semantic memory there that helps Tabnine be contextually aware of what's going on in the project, and respect that. Um, Other components, models for ranking, for filtering, for toxicity. I don't even know. There are so many kind of moving parts in this in the product. But maybe I would say there's like the model is one big piece. Semantic memory, vector memory are two other big pieces, and there are many small pieces around that. So now, in terms of there's the problem of contextual awareness. How do you provide a product that is aware of customer code is also very central to Tab9. And so we have both the machinery for fine tuning on the customer code base and the machinery for doing retrieval augmented generation, both vector based and semantic based, to provide contextual awareness. And on top of that, we have some additional symbolic semantic awareness in the IDE that provides additional hints for the model of what should be generated. So definitely contextual awareness is a central theme of the product that required a lot of work there. In Tabnine chat, there are additional aspects, including again the context awareness, but also limiting what gets generated, and in some alignment problems there that are also interesting. You also asked about deployment. So Tab9 is basically deployed as into a Kubernetes cluster. It's a bunch of services, inference, and the others that I mentioned can deploy Tab9 in your own virtual private cloud, or can deploy Tabnine also completely air gapped on your hardware. And we have a number of customers that have gone the kind of hardware route and have their own air gapped deployments of Tab9, which I think is kind of
As far as the model architecture, I'm also interested in understanding what your approach has been and some of the experiments that you've done of, do you just have one monolithic core model that does all of the programming languages and code generation, or have you broken it into I guess, a core model, but then different models with subspecializations and some of the ways that you think about the interaction across those boundaries.
Yeah, we kind of oscillate architecturally. We have taken the approach of having multiple models, and definitely there have been times that we served, I don't know, maybe up to 8 different models serving different programming languages or even different parts of the software universe, like different stacks. I think these days we have converged to like maybe 3 or 4 different models, and they serve different facets of the product. So different parts of the product have very different latency cost trade-offs. And when you come to optimize Tabnine and make it possible to run Tabnine also on premise without requiring an entire GPU farm there, you need to optimize the consumption in different facets of the product. Some facets are very latency sensitive, right? So for code completions, you want to get generation as you type. And so the model depth cannot be very large for that if you're optimizing for latency. And that kind of in turn derives other parameters of the model, and you get to certain model sizes if you want to do that economically with very low latency. Other facets like chat are maybe less latency sensitive, and you can go with much bigger models, and kind of you have more leeway on how you handle the inferences and how you deal with in-flight requests and batching and all that. There are a lot, like inference is hard. I don't think people realize how hard is inference when you try to do that economically at scale, like when you try to serve in Tabnine SaaS, right? When you serve hundreds of thousands of users and you have to do that economically. I think it becomes just the inference becomes a hard problem that then also dictates the kinds of models that you can and do deploy in production. And as you said, specialized smaller models sometimes allow you to, like a sparse architecture, sometimes allow you to do things with better latency and also more cost effectively.
This episode is brought to you by Datafold, a testing automation platform for data engineers that finds data quality issues before the code and data are deployed to production. Datafold leverages data diffing to compare production and development environments and column-level lineage to show you the exact impact of every code change on data, metrics, and BI tools, keeping your team productive and stakeholders happy. Datafold integrates with dbt, the modern data stack, and seamlessly plugs in your data CI for team-wide and automated testing. If you are migrating to a modern data stack, Datafold can also help you automate data and code validation to speed up the migration. Learn more about Datafold by visiting dataengineeringpodcast.com/datafold today. And while I was preparing for this interview, I looked to see how long Tabnine has been around, how long you've been working in this space, and I saw that Tabnine as a business was founded back in 2013. And I'm wondering if you can talk to some of the ways that your overall goals and approach to your core problem statement have changed or evolved over that period, and in particular, some of the ways that the advent of generative AI kind of shook up your ideas of what was possible.
Yeah, definitely. So, in fact, 2013 is an exaggeration because it was I was in a professor working on this like super part time just with tour. But 2017 we kind of decided that this is maybe something worth pursuing seriously and got funding. And so I would put the line I would draw the line on 2017 for a real company. But definitely when we started, I think we knew that we can do stuff by learning from millions of examples to kind of help you develop software better. The imagination was that all software will be written using AI. So that was the vision, I think, even as early as 2013 when we just like played with ideas. Initially, when we started, we said, okay, you will write code and we will present suggestions in a sidebar. Like next to you, as you write, we'll give you like the suggestions of what to do. And it was beautifully done, really. We had like a great designer back in 2017, super talented guy. It was the most beautiful product that I ever saw. I loved it. And everybody absolutely hated it, other than me. Like all developers in the world hated it with a raging passion. And the reason is that as you would type, things would refresh on the side all the time. So you're like, imagine that you start typing and kind of you have a sidebar that always changes all the time. So it's super distracting, even if every suggestion there is exactly the right one. And then one of our users said, like, hey guys, like, why don't you just like put that, do exactly the same, but make it as a code completion natively in the IDE. Just insert it in the right place and pick one. Just pick the best one because we said we'll show you several options you can pick, and we were totally kind of like very naive in the user interaction. And once we put that in as a code completion, I think then it clicked, and we got very good adoption starting in 2018 and 2019 when we expanded to additional languages. Then Tabnine really started to get traction. Yeah, I think I've been humbled by the progress. So back 2019, had you asked me if we'll be able to do what Tab9 is doing now, I'll tell you probably in a decade. I can't even imagine that this would be possible. And every day I'm kind of surprised and amazed and humbled, but what it can do. And as you know, as the entire research area kind of keeps progressing, I'm kind of amazed by the things that we are able to do these days. I think really, I think for me, in the last few years, I've kind of came to the I don't know my realization or speculation that quantity does breed quality, which is something I was highly skeptical in the past. So, like I said, piling more and more parameters will not make you that much better. And it looks like it does. So, it's, uh, I think maybe whether you do it like with a sparse architecture or keep on piling parameters into a dense model is besides the point. But these models become stronger and stronger, and I'm amazed by the abilities that we have in our hands today. Again, as I said earlier in the conversation, I think for many of the tasks, the human is the bottleneck. So your ability to describe what is it that you want and your ability to consume back what has been generated is the bottleneck. So the bottleneck is IO, so to speak, between the human and the machine, right?
If only we can figure out how to make humans multi-core.
Yeah, exactly.
In your work of using these generative AI capabilities to build a product that is focused on developers and their workflows, you mentioned things like latency being a challenge. I'm wondering if you can talk to some of the most complex aspects of customizing an LLM for this specific context of software engineers.
Uh, yeah, that's an interesting question. I think, as you mentioned, latency. I think we spend a lot of time on the granularity. So it's not necessarily the model directly, but again, how you interact with it. But what is the right granularity of generation? Like, should it be 5 lines, 20 lines, 200 lines? What are the boundaries? How do you make it easy for the user to consume the result? And this is happening also in test generation. Like how do you make the result accessible? Let's say I generated 200 tests for you. Uh, how are you going to, what are you going to do with that? Are they all valuable? Which one are the valuable one? How do you guide the model to generate the valuable tests and not just increase the test count? Right. So these kind of questions, I wouldn't say that the model per se is a challenge, but definitely everything around the model. Context awareness still remains a problem in this space because the one of the advantages of you as a human is that you know the entire project, you maybe know the entire organizational code base, what microservices are available, what other architectural decisions have been made, right? as we try to convey this kind of information to the model, there's both a limitation on what the model can capture, but also a limitation on how you phrase that, how you extract the information from, say, the code base or from the organization knowledge base and communicate that to the model in a useful way. So that's definitely another another challenge.
Another aspect of the problem is not just the capabilities, but also the accuracy and understanding when you've generated an accurate result and being able to build a feedback loop for the model. And I'm curious if you can talk to some of the ways that you think about the assessment and measurement of accuracy, given the fact that that can be a bit of a nebulous concept in software engineering because again, it comes back to, are the requirements accurate? So is the output accurate based on the requirements, or is it just that the requirements are inaccurate? And some of the ways
Yeah,
that you think about building those feedback loops into the successive training iterations of the model.
yeah, it's a really hard problem, and we are spending a lot of energy on evaluation. We obviously have our own evaluation harnesses that kind of, intuitively pick up a repository that we haven't seen in training from GitHub or somewhere, erase some parts, try to complete them, see how well we did. But even measuring how well you did is a kind of a tricky concept. What exactly do you measure? Each metric has its own problems, and so we have like a slew of metrics that we learned how to kind of weigh them together and how to kind of get a read of whether the model is better than the previous one or not. So definitely a lot of lab evaluation. In terms of users, I think the ultimate test, at least for code generation, is whether the code that we generated got adopted or not, right? And so that's slightly easier, but also, as you said, it's not necessarily equivalent in all users, because we found out some users take it even if it's completely wrong, and then they massage it to what they want, right? And some users prefer not to take it and just write something very similar themselves. And so the signals are also quite tricky to analyze. That's for code completion. But for code completion, I feel like we have a pretty good read based on both the kind of internal harness and metrics and on user feedback of accepted slash rejected set completions. For chat, this is much harder because the both the specification, like the question of what you asked, is kind of more fuzzy often. It's more natural language heavy, the interaction. It's multi-turn, right? So it's there's like more than one iteration in which you get the requirement specified and refined, and then the result may or may not be taken by the user based on, it may be too long, so the user didn't take it. So there are all sorts of harder to analyze signals when you're analyzing the score or the kind of evaluation of chat. Again, a lot of lab evaluation there, including human tagging. So we employ some human tagging teams to give us feedback and to help us feedback the model. Some efforts around RLHF, obviously. We do generate multiple answers in Tabnine chat, and we see how users interact with that. Allows us to get some read of reality. But these evaluations are very, very tricky, especially for chat that is generating code, because just as you said, Tobias, the spec is unclear, right? Somebody wrote some natural language specification and then got some result, which is not clearly completely wrong or completely right, and it's very hard to evaluate. Yeah, even I would add, even using humans is very hard to evaluate. Like even if you give me the results, right, or you give our human team like the results and say, was the chat correct? Was timeline chat correct or not? It's pretty hard.
Another layer to that challenge also is shared vocabulary, where things like, if you're in the conversational aspect of write me a module that does X, where you're saying, oh, I want you to use dependency injection, versus somebody else says, oh, I want you to use inversion of control, and just some of the ways that the names for the same concept are different across different teams and how you manage to map those to the same inputs for the model. I'm wondering how that plays out.
Uh, Yeah, the honest answer is I don't know. It's hard. As you said, I I think we're not there yet. I think we're hitting a lower kind of lower bar of challenges on the human expressivity of people saying, whatever, write me a sorting algorithm. So, you might get bubble sort and you say, oh no, I didn't want bubble sort, I want something else. So you get some other code and say, but actually, this is totally not what I wanted because I wanted to make a library call. I didn't want you to re-implement the entire sorting algorithm, right? So now this entire interaction, is it good or bad? Should you have given like the library call as the first answer for the first interaction? You don't know how to grade that, right? And we're seeing a lot of, this is like a trivial example, but seeing a lot of those interactions. I think, as always, with these technologies, they are successful when the humans adjust, right? So I think it's not about tuning the model, so as to tuning the humans, right? It's like it's kind of calibration of expectations, and people learn. And we see that with users, they learn how to write the questions in a way that is helpful for kind of cutting through to the right answer on the first interaction. It's not different from people learning how to use Google, right? It's kind of same kind of skill, and I think developers will improve in doing that. So it's not, people like to call it prompt engineering, but it's not really that. It's not as far as that. It's just like learning to communicate with an assistant that is maybe very smart, but very limited in its ability to communicate. Right. So
Yeah, I was going to ask you about that idea of prompt engineering and being able to share a set of prompts that produce a particular category of output, or some of the ways that you think about training humans. And the biggest question, I guess the main question I'm driving at, are what are the aspects of customer education that you find yourself having to come back to as people are onboarding onto Tabnine?
there's definitely some aspect of that. Like, for example, when you're doing code completions, people write comments, right, to kind of prompt the model. But in their head, they're thinking chat. So they write comment like, question, how do I do blah, blah? And this is not how the model has been trained for code completion. Code completion is not a conversational model. So you're kind of actually, the model expects comments as they would appear in actual code, right? And when you start to write these elaborate stories as comments, you're actually distracting the model. So that's part of education that you have to do. On the chat side, again, I think most of the education is like be short and to the point, kind of don't tell like the elaborate stories because again, you're distracting the model in a sense. But I think people already get that, right? And
Yeah, and to the point of putting a conversational mode into your code comments, it's also bad form for the actual longevity of the project, because you don't want a
yeah,
very verbose comment. You just want to know, what is this trying to tell me and why do I care?
right. Yeah, absolutely. I think one interesting thing in actually test generation, which I found interesting, we do test generation from the code itself right now, right? So it's like the opposite of TDD in some sense, right? You don't say what are the requirements, you look at the code and you generate a test for it, but you're not given a spec, right? You're not given a specification unless there is some comment there. So for test generation, for example, it is helpful to have a comment that says what is the code expected to do. It helps test generation test what you intended for the code to do and not what the code does, right? So these kind of things are kind of usability issues that should be solved probably in a different way in the product, right? To kind of ask you for the spec in natural language. But right now, that's the way that they work.
Yeah, it's interesting because there's a few libraries I've come across where the idea is that in the comments you write the contract for the function, which it says, okay,
Hmm.
this accepts these inputs, it should be within this range, etc. And so that it's intended to help with constraining the tests, or informing the other developers of how this function should be used, but it also has the benefit of speaking to the model in the language that it understands.
Yeah, exactly right. And yeah, I think if people, the mental model of the models should be of the AI assistant should be, I'm working with this other person who is very smart, but I have to communicate extremely clearly with. Otherwise, they get distracted or derailed, right? So that's the mental model.
And in your experience of building Tabnine, particularly in your latest iterations of using these generative models for code suggestions, code creation, I'm wondering what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
uh, so people use it. Okay, so I've seen it applied in strange ways. So maybe my application is that I do all my writing with Tabnine. So emails and meeting summaries, everything I write in Sublime using Tabnine just for the kind of the English model. I got used to it. I don't think it's extremely unusual, but that's just me. I recently had some people interested in using it to migrate COBOL code to more modern languages, which I thought would not really work that well. But again, if you calibrate your expectations properly, I think it's not that bad. So again, migration project as a whole is probably bad use for Tabnine because taking one code base and abracadabra make this COBOL into Java is just not going to work architecturally, right? The architecture of the application is going to be completely different. But if you have like this opaque COBOL code and you want to massage it into some Java procedure that does something that you can understand and maybe help it a little bit on the edges manually, I think that is an interesting or at least an unexpected use from my perspective. I've seen people trying to do magic TDD or TDD to the extreme, like writing the tests and trying to force Tabnine to generate the code. It kind of works in small cases that you can fit all the test cases into the context and whatnot. But I think that's an interesting direction for the future. I think something like that would happen in certain domains, right? That you just write the tests and hit a button and get the code. So I can definitely imagine that as a viable use case of the technology moving forward. Yeah, I think that's roughly it at the high level. Yeah.
From the test creation perspective, too, it sounds like you would probably want to have your test harness pre-configured and you're just filling in the individual tests rather than just, I have absolutely no tests, write some for me.
Yeah, yeah. So it has to be something like that. Yeah, some balance.
And in your experience of building this product, working with the developer community, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Yeah, there are. I found out that people are very passionate about languages that I didn't know existed, and so I think we get a lot of requests. Again, it's just my ignorance, not to say that the language is bad in any way. It's just that I was not aware of like the amount of code that is being created there. Like for example, PowerShell was one example that the community was very excited about using Tabnine for PowerShell, and I was like, "Hey guys, I don't even know that it works, right?" But definitely that would, I think those languages were kind of surprising. Maybe another surprising aspect is kind of the very logs of the world, the hardware languages that again were completely off my radar, and people just came and said, "Hey, it kind of works for these languages, but can we make it better?" And so we are making it better for these languages, and it's interesting. It's very different than what I'm used to, at least as a software engineer.
In the space of software engineering, software development, development teams, I'm wondering what are the cases where you see AI and AI assisted development as the wrong choice?
Ah, that's a good question. I think for code generation, probably if you are working on like the one-off algorithm that is very clever, and especially if you're working on some, I've worked in the past on like concurrent low-level algorithms. So I can imagine if you're working on a concurrent low-level algorithm that has a lot of requires a lot of global reasoning, subtle reasoning, and you're the only one in the world that ever wrote this algorithm, right? It's not like you're reinventing some concurrent garbage collector or something. Like you are legit. This is your algorithm first time, then probably AI code generation is not your best friend at this point, right? It's a very subtle kind of puzzle that every piece has to fit neatly together with global reasoning. And I think it's probably for the generation part, it's maybe not the best use of the tool. This is really a task that is heavy on human intelligence and human reasoning right now, could change tomorrow, right? When the models become even better. For other aspects that are not generation, I think AI assistance is always the correct choice. Like if you're using it to review your code or to do test generation or do stuff like that, even if the AI is wrong, it teaches you something because if you say review this code and AI says gives you some comments, say like this comment is wrong, but I understand that the code is written in a way that could mislead you to that reasoning. So let me maybe restructure the code to make it more obvious to you and to the next human reader, actually. So I'm doing a service not to the AI. I'm not in service of the AI. I'm in service of future Iran that will come to this code a year from now and say, who's the idiot who wrote that, right? Because I don't understand. And so I think for review, for test generation, AI assistance is always the correct choice, even for the one-off algorithm.
And as you continue to build and iterate on Tab9 and continue to play keep up with the rapidly evolving space of large language models, what are some of the things you have planned for the near to medium term or any particular problem areas that you're excited to dig into?
I'm super excited about code review. So in code review, we've worked on the problem now. I think current code review product is version 3 of the product. So we had version 1 maybe a couple of years back. I loved it. Everybody hated it. I think you start to see a theme here, right? So that the developers on the team said like this is mostly distracting us. It's giving us comments, like no 2 out of 10 are what we want, and the other 8 are like we just have to fight the tool. So we don't want that. Version 2 was much better. And I think now with version 3, it's actually really useful and valuable. So definitely excited about code review coming out later this year. Integration with non-code sources is another thing that is coming out, and I'm super excited about the ability to get all of Tabnine, be aware of Confluence and Notion and Jira and other sources of information that are non-code and this integration that we've been working on for a while now, it's really hard. It's a really hard one. People think, oh, you'll just slap a vector database over the documents and you'll be fine. No, far from it. It's a really tricky one to make useful, and I'm very excited about that because informing code generation, test generation, all other tasks of Tabnine with some architectural details, with some other non-code kind of source of information, really changes how the product reacts, right? It's like kind of you suddenly understand like it starts to use a microservice that has not been defined anywhere other than the docs, right? And you start to see interesting things happening because you've informed it in a more general context, like a human has, right? So this is like these vertical or sorry, these the horizontal actually integrations of with other data sources. I think are beginning to inject the level of human expertise that you'd expect from a human into the product. And I think as we improve that, also surfacing that in code review, that the product will become immensely more human-like.
Yeah. Leveling it up from an intermediate to a senior engineer.
Kinda, yeah. I guess, yeah. I guess that's a good way to phrase it. Yeah, thank you.
All right. And are there any other aspects of the Tab9 product itself, the overall space of AI assistance for software engineering, or the rapidly evolving area of large language models that we didn't discuss yet that you would like to cover before we close out the show?
I'm very curious about this space. I think we will not go that far with Tabnine. So I'm just like back in 2016 maybe. I, I worked on this kind of crazy idea of learning programming from YouTube videos. So there are so many tutorials on YouTube that teach you how to do certain things with programming. So I actually had very nice work with a student on like how to learn from those video tutorials, and when I have time someday, I'm curious about going back to that and maybe generating tutorials, programming tutorials completely automatically. I don't think we'll do that in Tab9 anytime soon. I think the roadmap is really full, but something there feels right. I mean, like programming tutorial videos and ability to generate them automatically sounds exciting to me.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest barrier to adoption for machine learning today.
Two of them probably. I think one is definitely privacy and security, as we see with Tab9 customers that don't want to send all their information to outside the org or to some big brother. So definitely a barrier to adoption there on kind of maybe architectural side. On on the product side, I maintain that the biggest adoption is the human. We need to find better ways to interface with humans. This is not only for software creation, this is for any Gen AI product. You need to somehow find the right level of representation to make it easy for your user to kind of say, aha, yeah, this you just generated what I wanted, right? And this is maybe with Mid Journey, it's easy because you get the princess riding the unicorn. But with other products, it may be very, very hard and may require maybe even phrasing a different language for communicating back the result, right? So this is even if you think for us in Tab9, one of the kind of high level thoughts is like, should there be like a different language in which you communicate the results? Even if you ask for a C program, like maybe I shouldn't show you the 2000 lines of C program, but kind of summarize for you the main ideas in this C program and say, yeah, okay, I got it. That's what I wanted, right?
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing on Tab9. It's a very interesting product, definitely very exciting to have these capabilities for people working in the software space. So, definitely appreciate all the time and energy that you and your team are putting into accelerating software engineers. And I hope you enjoy the rest of your day.
Thank you very much. Thanks for having me. It was great.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.